Good morning, boys and girls. So today we are going to continue practicing finding the area of a triangle. And recall yesterday we have the formula A equals 1/2 times base times height, or remember 1/2 is the same thing as dividing by 2. So we can either use this formula, which is the same thing, A equals base times height, and then divide by 2. Okay, so either formula works. You can use whichever one. I like using this one when my base and height are fraction numbers, and I like using this one when my base and height are either whole numbers or decimals, but either one works, okay? So again, the area of a triangle is 1/2 times the base times the height. And again, you only need two sides from your shape to help calculate the area. The base and the height, and together, remember, they need to make that right angle. So yesterday we focused on the right triangles, okay, because those ones were a little bit easier because the right angle is easy to see, so we can easily find the base and the height. Today we're going to focus on the acute and obtuse triangle. And you should have learned what acute and obtuse is in your previous grades, but I will review it as we go along. So remember an acute triangle, acute, like it's little, it's cute. Acute means that all the angles, remember, triangles have three angles, right? Acute means all angles are less than 90 degrees. Oops. Let me just draw a line here so that I don't get mixed up with the other lesson. Okay. It's acute. They're little, they're cute. They're less than 90. Okay. And these are what these triangles look like. They're acute. This angle is less than 90, so is that and that. They're less than this 90-degree angle here. Okay. So the reason why I split it up is so that you can practice finding the base and the height when you have an acute triangle. So let's start off with this one. Now remember, this is on grid paper, so it doesn't tell me the length of the base and the height like this one here. So instead of that means we have to actually count it using the sides of those squares. Okay. So our base, remember, is the bottom usually. Okay, that's the bottom of our triangle. And then now you have to determine the height, okay? This time in an acute triangle, the height isn't one of the other sides. In a right triangle, the base and the height is the sides of the actual triangle. But in an acute triangle, the base is one of the triangle sides, but the height is not. Okay, remember the height is how tall the triangle is. From the tallest angle, like the top of its head, the tallest angle, to the bottom, the base. So if you see here, this here is our tallest angle right there. So the height has to be dropped down from that tallest angle. It's the distance, remember, from the top of the triangle, the highest angle, to the bottom, the base. So this time the height has to be something inside. It's not one of the sides of the triangle. And that's very important that you understand that, because in some problems, you're going to get the length of all the sides and you're not going to need all those. You're only going to need, remember, the base and the height. So the height is the tallest angle dropped down to the base. So it's not actually one of the sides of the triangle. So here is our base, here is our height, and here is that right angle symbol right there. Okay, so now we can calculate it because we found the base and the height. So now let's count how long each side is. So this is 1, 2, 3, 4, 5, 6. This is 7 because you got to go all the way to the tip, to the end. So this is 7 units long. We say units because we don't know if those squares are measured in inches, feet, so we just call it units. Now the height of the triangle again is up here to down here. So let's count that. 1, 2, 3, 4. So the height is 4 units long. And there you go. Now we have the length of our base and our height, and together they're making that right angle. That's very important that it's the two that make the right angle. Okay. All right. So first step, write our formula. So I'm going to use 1/2 times base times height. Second step, we're going to substitute. So 1/2 and put my multiplication symbols. Base is 7 times height is 4. And then here you can do a couple of things because of the commutative property of multiplication. I can go left to right, or I can first deal with my whole numbers, 7 times 4, and get 28, and then bring down the 1/2, and then times that, half of 28. Well, half of 28 is 14. And there you go. And don't forget, and I saw a lot of you forget, um, on your work page, you need to have your units of measure. We need to attend to precision. So since we don't know what units these are, this will be units. And don't forget, area is squared. You have to put that little power of 2 on the units. If it's feet, inches on the units. And this is now the proper answer. The area of this triangle is 14 units squared, or 14 squared units. Okay? All right, we're going to try that again. So let's put a little star here with acute angles, right? The height is not a side of the triangle. Okay, it's very important. The height is not going to be a side of the triangle. Okay, so there's one side of the triangle, 2 and 3. Okay, the base will be one side, but the height will not be. It will be have to be dropped down from the tallest angle. Therefore, we're going to ignore whatever that side is and that side. Okay, all right. Next problem. We have here a triangle. It looks like it tells us this is 34 inches long, and it says this is 14 inches long. Okay, it doesn't tell us this side length, and it doesn't tell us this side length. The reason why is because we don't need it. All we need again is the base and the height, and together they need to make that right angle. And we see that right angle symbol right here. Okay, and notice this is a dotted line. It's a dotted line because that height is dropped down. That's what that means, that dotted line, that's the height is dropped down. Okay, it's not part of the length of, it's not part of the sides of the triangle, but it's the height is dropped down, so you can see where to measure it from the top of the highest angle, and that's the highest angle, to the bottom space. All right, so there's our base, 34 inches. Okay, and again, the highest angle in this triangle is up here. You see there's no other angle. And then we drop down the height. And the height is 14 inches. And there we go. We have our base and our height together. They make that right angle. So this time I'll use the other formula. So base times height divided by 2. Remember, we have to write the formula. And then we plug in our 14, our 34 for the base, times our 14 for the height, all over 2. And I'm just going to use my calculator for this one. I'm going to simplify the numerator. So turn on. So 34 times 14, that equals, so far A equals 476. Divide that by 2, and that is 238. And there we go. So that's our numerical value. But now we have to deal with the units of measure because we're dealing in geometry. So our unit is inches, so I'm going to put inches. And remember, because we're dealing with area, area is always measured in squared inches, so I got to put the little power of 2 above the unit measure, okay? And that's what I mean. You can't forget your units of measure, okay? And then there is my answer. 238 inches squared, or 238 squared inches. You can say it either way. Okay, so that's the acute triangle. So in the acute triangle, acute, they're little tiny acute angles. All the angles are less than 90 degrees. And the base is still one of the sides of the triangle, but the height has to be dropped down from the tallest angle. Okay? All right, next is our obtuse. Hopefully you remember what obtuse means. When I think of obtuse, I think of like obnoxious. People are obnoxious, you know, they have big mouths. So obtuse, I think of big, right? So in respects to an angle, the 90-degree angle, an obtuse triangle has to have one angle that is greater than 90. So if this is 90, one of them has to be greater than 90. Okay? So obtuse triangle has one angle greater than 90 degrees. That's what obtuse triangle is. So as you can see, these triangles, you can see the one that has this angle here is going to be greater than 90. This angle here is the one that's greater than 90. Okay? So these are obtuse. All right, so on the grid, we have to figure out which side is the base. So as you can see here, if I use this side, I really can't count how long each side is because it's at an angle. This one here too. But look at this side. This side matches with the squares. That's the easiest side to count. So that would be my base. So again, we gotta find our base. And there we go. Now again, our height. So if that's my base, I'm gonna turn my paper around. That means that's the bottom. That means my tallest angle will be this one across from it. Okay. And just like the acute triangle, the height of this triangle is not going to be the other sides of the triangle. It has to be dropped down. So this is the tallest angle and it has to be dropped down straight 90-degree angle to the base, which it does, and that creates that 90-degree here. And that is the height there. So again, it's not also one of the sides. Okay? So now let's calculate that area. So we have to count how tall it is, or the base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 units long. Okay, then the height, which is this here, 1, 2, 3, that's 3 units long. So there is our, thank you, Leland. There is the base and the height length. So now we know we're dealing with a triangle, so let's use our formula. We use base times height divided by 2 because I have whole numbers. Okay, substitute base is 11 times height is 3 divided by 2. Multiply the numerator, 11 times 3 is 33, and divide that in half. So I know that's not going to go in evenly, and that's okay because we can have decimals. So if I divide 2 into 33, that goes once. You could use your calculator, but I'm not. 16, that's 12, 1, add a decimal and a 0, decimal up, 0 down. That's 16 and a half. So the area is 16.5. Since we don't know if these are what units they are, we're going to use the word units. And then we're going to have this squared, remember, because area is measured in squared units. So this triangle has 16 and a half units squared inside of it. And that's that space inside here. And we could probably count them and put things together to count all that. All right, now this obtuse triangle is positioned a different way. Okay, so here we had to drop the height inside the triangle. But here, as you can see, they're dropping the height outside the triangle. So that's a difference with an obtuse triangle. Sometimes the height has to be dropped from the outside, and that's okay. So again, we want to label our base. So you can see our base is right here. And our base is just this part of the triangle. Okay, and that's 15 meters long. Now the tallest angle is out here. Happens, okay? This is an angle, an angle, an angle. A triangle has 3 angles. That's why it's called a triangle. Well, these 2 angles here are down here, but this last one is all the way up here. So that's the tallest angle. So that's where we're going to measure the height. That's like the top of its head. But then remember, we have to drop the height down to the base. Well, the base is all the way here, okay? Well, the reason why this is dotted is because this is what we call extending the base. We're going to extend that base. Like this is the floor, but we only want to measure, but only this much of the floor is the length we want, okay? But we have to extend it so that we can drop that base down, so we can drop that height so that we can make that 90-degree angle. but 15 only is this. We just extend the floor a little bit longer so that we can measure, we can drop it down to make a 90-degree angle. And so there is our height. Okay. So our base is 15, our height is 11. And there we go. We have our base and our height. So I'm going to use A equals, this time I use 1/2 base times height. A equals 1/2 times base is 15, height is 11. All right, so I'm going to use my calculator, and I don't want to do all. The other one was easier to do by this one, 15 times 11. Leland, go get my phone on top of the box over there. Sorry, you guys, my phone's alarm is going off, and the baby is still sleeping. We do not want her to wake up. So that's 165 times a half. Okay, so that means I'm just going to divide that by 2. So divide by 2, I know I'm going to get a decimal. So 82.5. 82.5. And now we have units, and that's meters, and that has to have a little power of 2, squared meters. And there we go. 82.5 meters squared is the area of this triangle here. Okay, and so now you should know how to find the base and the height of the 3 types of triangles. If you're unsure, please make sure you go back to your notes and take a look at, okay, does my triangle look like this one more or like that? Okay, but when you have an acute and an obtuse triangle, the height is not going to be, okay, it's not going to be one of the other sides of the triangle. The only time the height is going to be one of the sides of the triangle is if it is a 90-degree angle, if it's a right triangle. Then I'll use 2 of the sides. Okay, so I hope that that clears that up. And so today you'll be practicing finding the area of these type of triangles, or all 3, but mainly focusing on these 2, with fractions and decimals, whole numbers mainly. And please don't forget, and I saw some of you forget to use the correct steps. I want you to write the formula, whether you use 1/2 base times height or base times height divided by 2. It doesn't matter. You're still doing the same thing. But I need the formula. I need to see you plug in the numbers, get your answer with the right units of measure. Okay? Don't forget those are squared units. So today you're going to be uploading your work again because I want to make sure that you are doing the right steps. Okay? All right. So the next thing you're going to do now is you're going to go to Khan Academy, and you're going to do, they have one lesson there that you're going to do, and then you have your practice. So if you have any more questions, you can see me during my office hours at 1:40 for a live Zoom meeting. Take care. Excuse me. Oh, shoot, I didn't stop recording.